Have you ever gazed at the starry expanse of the night sky and wondered, are we alone in the universe, or are there other universes out there just beyond our reach? Imagine the universe. It's everything we can see, touch, and observe. From the minuscule particles that make up the atoms in our bodies, to the far-flung galaxies that twinkle in the night sky, it's all part of our universe. This grand cosmic stage where the drama of existence unfolds is our home, our one and only universe. But what if it's not the only one? What if there are other universes out there, just out of our sight, beyond the reach of our most powerful telescopes? This isn't just the stuff of science fiction. It's an idea that many physicists take seriously. It's called the multiverse theory. The multiverse theory proposes that our universe, vast though it may be, is just one among potentially an infinite number of other universes. Some of these universes may be similar to ours, with galaxies, stars, planets, and perhaps even life as we know it. Others might be radically different, with unique laws of physics, different dimensions, or forms of matter and energy we can't even begin to comprehend. These universes aren't just distant regions of our own universe, they're entirely separate realities. They're like bubbles in a cosmic bubble bath, each one containing a different universe. This collection of universes, this multiverse, is the grandest, most mind-boggling concept in the realm of cosmology. So how did these universes, if they do exist, come to be? Were they born from the same Big Bang that created our universe? Or did they spring into existence in other ways, perhaps through cosmic inflation or quantum fluctuations? If there are indeed other universes, then how did they come to be? This question, among others, will guide us as we delve deeper into the mysteries of the cosmos. The question isn't just academic. The answers could redefine our understanding of reality itself. To understand the possibility of other universes, we must first understand the origins of our own universe. Our journey begins with the Big Bang theory. Now, when we speak of the Big Bang, we're not referring to a colossal explosion, as the name might suggest. Instead, we're talking about the rapid expansion of matter from a state of extremely high density and temperature. This was the birth of our universe, a singular point of creation around 13.8 billion years ago. But what exactly happened at the moment of the Big Bang? Well, to be precise, we don't know. The laws of physics as we understand them break down when we try to rewind the clock to that primeval instant. But we do know that a fraction of a second after the event, the universe began to expand at an incredible rate. As the universe expanded, it cooled, and particles of matter started to come together to form atoms. These atoms then grouped together to form stars and galaxies, and over billions of years, these galaxies have moved further and further apart. This expansion is still happening today. In fact, not only is the universe still growing, but the rate of its expansion is also accelerating. So what does this have to do with the possibility of other universes? Well, the Big Bang theory only explains the observable universe, that is, everything we can see or detect from our vantage point in space. But if the Big Bang was a kind of cosmic seed from which our universe sprouted, could there be other seeds out there? Could there be other Big Bangs leading to other universes? The Big Bang theory explains the birth of our universe, but could it also hint at the existence of other universes? These are the questions that make cosmology so thrilling, and they're the questions we'll explore in the next part of our journey. Let's delve into a mind-boggling concept that links the Big Bang to the idea of a multiverse: cosmic inflation. This theory, as audacious as it is fascinating, suggests that our universe underwent a rapid exponential expansion in the blink of an eye immediately after the Big Bang. Imagine, if you will, a tiny infinitesimal speck of intense heat and density. In a fraction of a second, this speck expands to an astronomical size, much faster than the speed of light. This is the heart of the theory of cosmic inflation. It's like a balloon being blown up, but on an unimaginably grand scale and at an unfathomable speed. This theory was initially proposed to explain some puzzling aspects of our universe, such as its uniformity. It's a bit like if you and a friend were to each throw a handful of confetti into the air. Despite the confetti being thrown in different directions and at different speeds, it would create a similar pattern each time. Just like the confetti, our universe, despite its vastness and complexity, is remarkably uniform in terms of temperature and density. But here's where things get really interesting. If cosmic inflation did occur, it could have implications far beyond our own universe. Some scientists suggest that our universe could be just one of countless others, each born from its own inflationary event. This is the idea of the multiverse. In this scenario, each universe could have different physical laws, different dimensions, even different kinds of matter. It's a concept that takes the term diversity to a whole new level. We might share this multiverse with universes where time runs backwards, where gravity is repulsive, or where light doesn't exist. The concept of multiple universes is fascinating, but is there any evidence to support it? While the idea of other universes may seem like pure science fiction, some scientists believe there may be evidence to support it. Now, let's dive into the fascinating world of cosmic microwave background radiation. This radiation, often abbreviated as CMB, is a relic from the Big Bang itself, a faint whisper of light that permeates the entirety of our universe. Some researchers argue that specific patterns within this radiation could hint at collisions with other universes. Yes, you heard that right. Collisions with other universes. As incredible as it sounds, these cosmic bruises could be the tangible marks left by neighboring universes in the vast multiverse. However, it's not just from the macrocosm of the universe that we find hints of other realities. In the subatomic realm of quantum physics, there exists a theory that suggests multiple realities. It's called the many worlds interpretation, a theory that posits every decision or action that could happen does happen, each in a separate universe. It's like a tree branching out into countless directions, each branch representing a different outcome, a different reality. But before you start packing your bags for a parallel universe where you're a rock star, it's crucial to remember that this is all still theoretical. While the evidence is intriguing, it is not yet conclusive. We're still in the early stages of understanding these complex and mind-boggling concepts. Science is a process of discovery, and each new piece of evidence brings us closer to unraveling the mysteries of our universe and potentially other universes. It's also important to note that these theories, while exciting, are subject to rigorous scrutiny and testing. They must stand up to the harsh light of scientific inquiry and prove their validity. Until then, they remain fascinating possibilities, glimpses into a universe beyond our own, waiting to be explored. So, are we alone in the universe or not? Only time and science will tell. The quest for knowledge continues, and as we delve deeper into the cosmos, we may yet find answers to these profound questions. As we stand on the precipice of the known and the unknown, we can't help but feel a sense of awe and wonder. This, my friends, is the beauty of exploration, the thrill of discovery that propels us forward, even in the face of uncertainty. We are a species driven by curiosity. From the early humans who first gazed up at the stars to the scientists of today who peer into the depths of the cosmos, we have always sought to understand the world around us. But what happens when we encounter questions that seem unanswerable, mysteries that appear unsolvable? Do we shy away, retreat to the safety of the known, or do we press on, spurred by the tantalizing allure of the unknown? History has shown us time and time again that it is the latter which defines us. We are explorers, adventurers, seekers of truth. We are not deterred by the mysteries of the cosmos, we are inspired by them. In the quest to understand whether other universes exist, we have pushed the boundaries of our knowledge and our technology. We have explored concepts and theories that challenge our understanding of reality. And even though we have not found definitive proof of other universes, we have learned so much in the process. We have learned about the nature of space and time, about the origins of our own universe, about the fundamental laws that govern our world. These are not small feats. They are monumental achievements that have expanded our understanding of the cosmos and our place within it. So as we gaze out into the vast expanse of the universe, let us not be daunted by the mysteries that remain. Instead, let us embrace them. Let us revel in the wonder of the unknown, in the thrill of discovery, in the sheer joy of exploration. Whether or not other universes exist, the search for them expands our understanding of the cosmos and our place within it. So keep looking up and keep wondering. Keep